Alright, here we go. I'm going to try to make this short and sweet. It's late and I get to get up even earlier to go to an Angie. I'm excited. Just going to do like half a 7.4 here. What we're going to do first, it's going to seem like two completely unrelated things right now, and then tomorrow I think we'll put it together. Maybe. I don't know. We'll see. First thing, I don't know if you can tell or not, but I'm really not feeling making this video. Just not into it right now. But, oh well, here we go. Separable equations. These are differential equations. We've done a little bit of differential equation stuff, like when we did related rates. Those are kind of like differential equations. Hopefully these words make sense a little bit. Basically, a separable equation is like an equation with two functions in it at once. So if you have like dy over dx equals f of y times g of x. So you have one function in terms of y, one function in terms of x, and you have a derivative over here. Basically all you gotta do is get all the same variables on one side or the other and integrate it. So like we could divide both sides by f of y and then multiply both sides by dx, so those would cancel. And what we'd have is 1 over f of y dy equals g of x dx. And then you could integrate that and do some stuff. It'll make more sense when we do an example here. So let's do the first example. It says solve for y if dy dx equals xy squared and y equals 1 when x equals 1. Alright, kind of weird at first. First thing I'm going to do with this, notice this is dy dx, and then over here we have an x and a y, kind of the same as we had here. So I'm going to get all the x's on one side and all the y's on the other. That's why it's called a separable equation. In order to do that, I'm not going to square root or anything. I'm going to change this to just x squared, y squared. Now I'll divide by y squared to get it over there, and multiply by dx to get it over there. So I guess I can show a little work here. Multiply by dx, divide by y squared. So over on this side I'll have 1 over y squared dy equals x squared dx. So now, in order to solve for y, keep going here, I'm going to notice I have a function of y times dy, a function of x dx. So if I integrate both sides, if I take the integral, might as well change that to y to the negative second power and x squared dx. So if I do my integrals here, I'll have, let's see, that'd be y to the negative 1, negative y to the negative 1, that would go away, equals, let's see, that would need to be what, 1/3 x to the third. And then you got to add a plus c. And you really only need plus c on one side, because like having it on both sides is just redundant. It's just a constant. You don't know the value of the constant. So if you put 2 on there, you can just minus it to the other side. You still have a constant on one side. I mean, if that doesn't make sense, I can explain it again later, but hopefully it does. So now we've got this little thing going on, and we're trying to solve for y, but the problem is we've got a c in here, So how are we going to solve for y when we've got a c? Yeah, well, we've got an x in there too. That's kind of a problem. But not really. So we need to figure out what that c is. And we can do that fairly easily. Well, because we knew that y equals 1 when x equals 1. So we can go ahead and just plug those in. So I'll have negative 1 to the negative 1 equals 1/3 times 1 to the third plus c. Well, 1 to the negative 1 to the negative 1 is what? 1 over negative 1, so it's just negative 1. 1 to the third, so it's 1/3 plus c minus a third from both sides. So what do we got? C equals negative 1 minus 1/3. Bradley, what's the answer? Do it in your head. It's negative 4/3. Yay, so what's it all mean? What are we going to do? Well, now we go back to this, our negative y to the negative 1 equals 1/3 x to the third. But instead of writing plus c, I'll put in my c, which is minus 4/3. We've almost solved for y. It'll be in terms of x. We're not going to get a number. So get y by itself here. Let's get rid of this negative. So if I divide by negative 1 or multiply by negative 1, I'll have y to the negative 1 equals negative 1/3 x to the third plus 4/3. Now, how do I get rid of y? How do I get rid of that negative 1 power? Interesting. Not really. To do this, this is like 1 over y, right? Equals this. So basically, I mean, you can think of it as multiplying by y on both sides and then dividing by this on both sides. Or you can just think of it as flipping both of them. Either way works. And flipping this might not really make sense. So I'm going to rewrite this first before I flip it. I'll leave it as 1 over y right now. Notice they both have 3 as a denominator. So I'm just going to combine them to 3. And on top I would have negative x to the third plus 4. Now flipping them is a lot easier. Flip them both. Or, you know, however you want to think about it. I could show the work. Yeah, just flip them. Y equals, usually write the negative on top because it looks nicer. Negative 3, well no, that's not going to work because then I'd have to change that sign. We'll just leave it. 3 over negative x to the third plus 4. That's good enough. So that's that. You're going to have to do that in your homework. And I think the directions also say, what is it? Indicate the domain over which the solution is valid. Okay. So the domain over which the solution is valid, that's kind of a weird thing. All you have to do is think, where is this, where is this continuous? If it's continuous for all real numbers, then the domain of which your solution is valid is all real numbers. But the domain of this is not all real numbers because our bottom can't be 0, right? So what would make the bottom 0? Oh, I don't know. Let's check. Negative third x to the third plus 4 equals 0. Minus 4. Negative x to the third equals negative 4. X to the third equals positive 4. So x equals the third root of 4. So when x equals the third root of 4, that bottom part will be 0, right? Which means x cannot equal the third root of 4. But the only, how can I explain this? we know, okay, so x can't equal the third root of 4. So the domain over which our solution is valid, we know 1, 1 is a point. Well, so we know third root of 4, think of a number line, here's 1. Third root of 4, that's bigger than 1, right? It's over here somewhere. And it's this answer is continuous everywhere to the left of this. So that's where the solution is valid. It's valid from negative infinity to the third root of 4. Ow, it hurts holding this iPad. That's all you gotta do. Okay, let's move on. Like I said, that won't seem related to this next part at all. To do some of the proofs for the next part, you'd have to do this, but I don't think I'm going to do them. I don't think you want to. Do you remember doing exponentials in Algebra 2? Maybe a little bit last year, where we would do like, you have $100, you get, I don't know, this is fake, 20% interest per year. How much will you have in 6 years? So it was always y equals ab to the x, or that was your initial value, and we called b the multiplier or the generator or whatever. That still works, but there's another way that we never did. That's for when interest. Whoops.